Good morning to everyone. Today we are discussing very important block cipher algorithm, data encryption standard, that is DES. So this is D. Kumar from CSE Honors. Today we are discussing about DES. Okay. First we discuss about what is the aim of this session. This session is to understand DES algorithm and its vulnerabilities to attacks. So what are different types of DES attacks? What are the instructional objectives are? We can define DES algorithm and its components, explain the steps involved in the DES algorithm, describe the different types of attacks that can be used against DES. Fourth one, evaluate the security of DES and its suitability for modern applications. These are the instructional objectives. Next, learning outcomes. These are the learning outcomes. Understand the encryption, decryption DES, evaluate the strength and weakness of the DES algorithm in terms of security, identify different types of attacks on the DES algorithm, explain the techniques and methodology used in these attacks. These are the aim, instructional objectives and learning outcomes of the DES. What we are discussing in this session: DES introduction, overview of DES algorithm, DES encryption algorithm, round function of DES, permutation tables for DES, what is S-box, what are DES permutation choice 1 and 2, DES weak keys, cryptanalysis and DES. DES introduction. DES is one of the block cipher algorithm which follows Feistel structure. What is Feistel structure? In the Feistel structure, the plain text is divided into two halves, left half and right half. Already we discussed previously. Okay. For DES, data are encrypted in 64-bit blocks using actually 64-bit, by it is later converted 56-bit key. The algorithm transforms 64-bit input in a series of steps into a 64-bit output. So what is 64-bit input means? It is plain text. What is 64-bit output means? It is cipher text. Overview of the DES algorithm is here. Block size is 64-bit plain text. Key size is 64-bit. Later is converted into 56 bits. Number of rounds 16. Number of subkeys 16. Subkey size 48 bits. Cipher text 64-bit. So simply you can say, when are giving plain text 64-bit to the DES, we are getting cipher text 64-bit. Using with the help of key 56-bit, we are getting 64-bit cipher text. This is encryption algorithm. It uses two techniques: substitution, transposition. This algorithm mainly contains 16 rounds. Okay. Each round we have to control the operations. You can use the key, separate keys. We will discuss. So this is DES encryption algorithm. Okay. This is first we are giving 64-bit plain text to the plain text. So to the input, as input to the initial permutation. So after initial permutation, it is again we are getting output as 64-bit. It is input to the round 1. In the parallelly we are taking 64-bit key. So we are giving input to the permuted choice 1. It is a table like some values. So after giving 64-bit key to the permuted choice 1, we are getting 56 bits. So after left circular shift, we are getting again 56 bit. Again by applying permitted choice 2, again we are getting 48 bits. You see here, every permitted choice, the number of bits are reduced to 8, 64 to 56, again 56 to 48. Now from permitted choice we are getting key 1, and we are applying some data from initial permutation to the round 1. By getting these two, we are getting output 64 bit. This is the input to the round 2. In a similar way, we are going for all rounds, 16 rounds. Okay. Now round 2 takes input from round 1 output. Round 2 give output to the output of round 2 is acting as input to round 3. So finally we can say the output of previous round is acting as input to next round. Okay. After that, in the similar way, we are parallelly creating 16 keys. Finally, we are getting the round 16 data. After round 16 data, the data is again we are applying 36-bit swap. We are swapping a left hand side bit and the right hand side bit. We are swapping to where the data is divided into two parts, that should be swapped. Again, we are applying inverse initial permutation, where finally we are getting 64-bit cipher text. This is about DES encryption algorithm. Okay. Here parallelly we are generating rounds and as well as keys. Okay. Round function of DES. What is in the round function already discussed here? Left hand side, right hand side. In the left hand side only we are applying the function. So expansion permutation we are applying. So we are getting the 48 key here. In the similar here also we are getting the CI -1. This is a key di minus 1 right hand side of the key. Again applying left shift, again by left shift we are getting some same here, left by using left shift we are getting some value here, by using left shift also here also we are getting some value here. By applying permutation or permuted choice 2, automatically it should be contraction. So 28, 28, 56, 56 we are getting 48. So 56 bit data we are minimized to 48. By XORing with these two we are getting this output 40, again 48 bit data, again 48 beta is applied substitution choice S box, again the data is decreases to 32, 16 bits are we are replacing, so 48 to 32. Again we are applying permutation means just arrangements, there is no loss of data, again we are getting 32. So this data plus XORing with the left part we are getting right part. So this right part is acting as a left part. Here also same thing, CI DI, these are the inputs for the next round. Here this is also LIR of the inputs for the next round. Okay. This schedule for how many shifts we are in the previous we are seeing here left shift here. So how many bits are rotated? Round number 1 it should be only 1 bit, 2 also only 1 bit, 9 also 1 bit, 16 also 1 bit, but remaining rounds we are getting 2 bits to be rotated. Okay, schedule left shifts in each round. Permutation tables for the initial permutation table. Okay, so here first bit is 58. Okay, 50, 42, 34 like this. So we are permutation means rearranging the plain text bits. This is inverse initial permutation IP minus 1, IP inverse. So again these are the positions of the bits of the plain text. Next one, this is expansive permutation E. So this one, these 16 bits we are removing from the plain text, 32, 4 like this. Okay, only 32 are available. Okay, permutation function is a permutation function. Okay, here also we are giving 1, 2, 3, 4, 5, 6, 7, 8, 32 bits. We are just rearranging the bits only. There is no loss of data for this permutation function. This is permuted choice 1. Okay, permuted choice 1. In the permuted choice 1, what we are doing here, we are namely 8, 16, 4, 32, 40, 48, 56, 64. These bits are not appeared in PC1. Okay, permuted choice 1, these are not appeared. Okay, these arrangements of bits of plain text. Already we seen in the algorithm. Permuted choice, these are the bits arrangements of permuted choice 2. Okay, 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, 7, 8. These are also 48 bits. Some randomness we are missing some bits of the plain text. With permuted choice 2. S boxes. Already these are substitution box, also called substitute box. This S box takes 6 bit as input and we are getting 4 bit as output. Okay. For example, see here 6 bit long here B1, B2, B3, B4 by B. This is a block of data. Here B1, B6. So these 2 bits are acting as row of the matrix. It chooses the row of the matrix. So what is B1, B6 here in the example? With 2 bits. B1 bit means you are not giving example. Next slide we are giving the example. So 2 bits. Suppose 2 bits are B1 is 0, 0. It should be. So 0th row and the first row. B1, B6 are 0, 1. It should be first row. Just like binary format. B1, B6 is 2 means 1, 0. Means second row and means third row in our order. Okay, B1, B6, 1, 1 means third row, means fourth row. Okay, so the remaining bits acts as the column of the dates. Okay, column of the data. Okay, so by getting 4 bit long here, so we are getting ciphertext 4 bit long here by representation of RC, row column. Okay, we will see the example. This is the example. Bit here 1, 0, 1, 1, 1. What is the B1 here? 1. See here, B1 is 1. B1 is 1 here. Next B6 is 1. Okay, B1, B6. So what 1, 1 means third row. This is, so B1, B6 always indicates row. Remaining bits acting as column. What is the column value? 0, 1, 1 means 7. See here 7. Okay, third column 7. Okay, C equals 7, 0, 1, 1. Okay, this is example for how to using S box. How to are using S box. By using S box, we are finding the rows and column of particular bit. Okay, this is the key generation. Already we discussed earlier. So 28 bit, 20 bit, C0, B0. By using left shift, we are getting C1 DI like this. Okay, by using permuted choice, again we are getting left shifts. Again, every time we are using two parameter choices. Okay, so in this way we are generating the sub keys. Decryption. Decryption is the same algorithm as encryption except the same keys x1, k1, k2 are applied reverse order. What is the order we are applying k1, k2? We are applying k16, k15 like this, we are in reverse order. Okay, that is D's description. So we are getting the plain text again. Okay. Next, these are DS attacks. DS weak keys. DS is 16 48 bit keys generated from a master 56 bit key. Weak keys. Keys make the same sub key to be generated in more than one round. Result reduce cipher complexity. Weak keys can be avoided at key generation. These are the weak keys. 4 weak keys are available. Okay, using weak keys, the outcome of the parameter choice one in the DS schedule to round keys being either all zeros, all ones, or alternative 0 or patterns. Okay. Since all the keys are identical, DS is Feistel structure, the encryption function becomes self-inverting, that is encrypting twice with a weak key, original plain text. That is the problem here. So, by encrypting twice means we are getting original plain text only. So, that's why these are called weak keys. Okay. Semi-weak keys, which produce only two different keys, each used 8 times in the algorithm. We refer to the K1 and K2. They have the property that EK1, EK2 of x equal to x. There are 6 pairs of DS semi-weak keys. So, weak keys or semi keys are not considered as fatal flaws for DS. There are 2 power 56 possible keys for DS, which only 4 are weak and 12 are semi weak. Okay, so out of 2 power 56, only 16 are weak keys. Okay, considering weak and semi weak. Cryptanalysis or DS. We are applying brute force first here. These are known as plain text attack. Pairs of ciphertext and the corresponding plain text. Try 2 power 56 possible keys. DS challenges. A series of brute force attack concepts created RSA security. The security message is like this. First challenge in 1997, solved in 96 days. Message, the secret message is many hands make light work. 1998 EF Electronic Frontier Foundation non-profit organization machine costs 250K 3 days. Okay, they are decrypting the message. 99 distributed net and crack combined 22 hours 15 minutes. Message was see you in Rome. Okay, so by applying cryptanalysis we are attacking on the security system. So, to get the plain text. Cryptanalysis DS, we are applying now same DS. Each plain text measures 2 per 64 different ciphertext, but there are only 256 possible different key values are available. Encrypt the known plain text with all possible keys. Keep lookup table of size up to 2 per 56. Given plain text ciphertext pair, PC lookup C in the table. Okay, by using lookup table, we are using this one dictionary attack. DS uses 56 key. This raised concern about the brute force attacks. One proposed solution is double DS. So apply DS twice using 2 keys K1 and K2 encryption. This is like this C EK2 EK1P. So applying on plain text 2 times DS. So decryption also in the similar way we are using 2 decryption keys. We are applying ciphertext. This leads to 2 into 112 bit case. So it is more secure than DS. Okay. So, meet in the middle attack. To improve the security of the block cipher, one might get the idea to simply use 2 independent keys to encrypt the data twice, EK to EK1P. One might think that this would be square of the security of the double encryption scheme. In fact, exact search of all possible complex keys would take 2 per attempts compared to 2 per attempts required for searching single key. So, by using what you are getting a 2 per attempts you have to use. Okay. Meet in the middle. So assume that attacker knows a set of plain text ciphertext, that is EK to EK1P, where is the encryption function and K1 K2 are the 2 keys. The attacker first compute EKP for all the possible keys of key and store the result in memory. Second, afterwards he can decrypt the ciphertext by compute DK of C for each key. Any matches between those 2 resulting sets are likely to reveal the correct keys. So automatically once the matches are discovered, they can be verified within a second test set of plain text and ciphertext. The key size is n. This attack is used only 2 per n plus 1 encryption decryptions. So in contrast to the naive attack, which needs 2 per encryption decryptions. Okay. Differential cryptanalysis and DS. So the DS was resistant to differential cryptanalysis. At the time DS was realized, the others already knew about the differential cryptanalysis. S-box are designed to resist differential cryptanalysis. Against 8-round DS, such attack requires 2 per 38 known plain text ciphertext pairs. Against 16-round DS, attack requires 2 per 47 chosen plain text. So differential cryptanalysis is not effective against DS in practice. Okay. Linear cryptanalysis and DS. Another attack described 1983 by M. Matsuai. Instead of looking isolated points at which a block cipher behaves like something simpler, it involves to create a simpler approximation to the block cipher as a whole. It is an attack that can apply to an iterated cipher. The Masu showed that DS can be broken 8 rounds 2 power 21 known plain text, 16 rounds 2 power 43 known plain text, 40 days to generate the pairs, and 10 days to find the key. The attack has no practical implementation, requires too many pairs. Exhaust which remains the most effective attack. The table regarding DS strength against various attacks. Exhaust to pre-computation, Sujan 1 2 power 60 processing of 1, exhaust to search 1 negligible 2 power 55, linear cryptanalysis 2 power 43. For text 2 power 43, cryptanalysis 2 power 38, processing of 2 power 50, differential 2 power 47, for text 2 power 47, cryptanalysis 2 power 55, processing of 2 power 50. The weakest point of DS remains the size of keys 56 bits. Okay. These are self-assessing was asked in the examination. Explain structure of data encryption standard algorithm. The number of round it performs, what is the key length and effective key length in the DS algorithm. Explain why the effective key length is less than the actual key length. Describe the process of key generation in the DS algorithm. These are self-assessment questions. These are the reference one. Thank you.